the connection, and I don't keep checking if the connection is lost. Anyway, so here it is, right? So I've audited by 2, and this is what happens. Result is clear, neater, easier to read, right? So remember, ordering is done to make things easier to read. There, we are done. Now, none of these, like I couldn't do it. You're most welcome to try. I tried at least this one to see if I could do it using subquery or anything, but I couldn't make it work. If I tried, the last one I said, oh, was easy. I can pick up the size 6 from a table and match the IDs, but then I was not able to get the price. Because remember, subqueries work independently. And if they work independently, and you want to pick up a field from a table and then another field from another table, which is in a subquery, you can do it. And outer joins didn't make sense at all here, because there's nothing which is saying, oh, we are trying to look for something that is here and not here. Usually outer joins are very good when you say, oh, it's here and not here. We're trying to look for something that is in both the tables, or all 3 tables, or all 4 tables. So definitely inner join is something that is the easiest and the most efficient to work. Okay, so remember ordering, and I'll try to remember that in my exam also. That way you can also see your results clearly. And again, I may show you my results so that you can match, oh, my answers are okay. So that way you don't waste time double checking your answers. But enough practice in your assignment will make you do your exam quickly. You won't get 18 in your exam, of course. I'll have to reduce that number, but now you have 18 to do. But you are 2 people and you have 2 weeks. So and I am doing so many, like you're doing 18. I think I've already done 50 with you in different forms. So aim, and because this is the most toughest topic kind of when you work with tables, and you will never have a table in a database. It will always be more than 1 table, logically, right? 99% times it will be more than. So if you have to pick up data, what do you do? So this is one way of doing it, where you show your results. The second is you can always create a view of the different tables. You can pick up some fields from a table, another table, and just create a view. And the view also has an existence in your database. We'll talk about that next week. It just has to be, you just have to know how to do it necessarily, but I mean, that's all you need to know. Okay, so this is done. This will go back on Blackboard for you at the end of the class. Now open up your last one, which was the sports one. So open the one that was called sports. And again, they all came together to you. So in that week 219 zip file. So it's called sports Blackboard _ for BB. I'll open it and I'll save it in your folder so that I can find it. So it's Thursday and it's week 12. And there it is. And we will quickly go through what it is, and if there is anything, I've taken it again from somewhere. If there is anything that we don't like or we can improve, we will do it. Okay, so let's look at it. Let me tell you what it is. This is a database that has 4 or 5 tables, which is keeping information about some players, right? So the first table is about players. What's the name of the player? What is his number? Initials, the birth date, because when you play, you see there are teams under 16, under 18, and so on. So there is where the birth date will be important. The sex can be changed. Instead of character 1, we can go enumerated. Always better to use the best type. As I said, this is not my script. I mean, of course, I can't create so many scripts. But we can always change it to something which is better. I also changed the player number to unsigned. I said player numbers cannot be signed, so I added unsigned to it. It can be int. You can go with a small int, but I'm not sure how many players there are. And so I kind of left it at int. But this definitely can go MF. Enumerated, remember enumerated, you can only enter the 2 values MF, small m, small f into this field. Better than character, because character could be anything, A, B, C, D, question mark, period, quotes, double quotes, anything which we don't want. So that definition can be improved. We've already looked at year. You looked at it in one of your assignments. With year, we don't have to say unsigned. It is automatically unsigned. With date, we don't say unsigned. It is automatically unsigned. Now, this programmer has chosen to divide the address like this. So instead of having one address field, he has a house number, a street, a postal code, and a town for whatever reason, right? So again, as a programmer, when you start creating tables, you have to think of what fields do I require. Will address as one field be good enough? You can keep it as a field. Or do I need it to be split up into these different parts? Because maybe you will be searching on town, right? Or I mean, you don't search on house numbers and streets, but maybe on town, like maybe on provinces in Canada. So that teams in the same province, we know from where you are. But this programmer has chosen to put it in 4 different fields, which is okay. And maybe he's thinking, oh, the definition of first normal form, every field must be atomic in nature, cannot be broken down. But I repeat, guys, atomic doesn't mean that it can be broken down is not a very good definition for first normal form. It used to be years back. That's the definition I learned as a student, but the definition says a table is in the first normal form if there is a primary key and there is no repeating data in a field. So in an address field, you have 1, Georgian Drive. That's not repeating data. I mean, repeating means, for example, I said, what are your favorite sites? Then it's repeating data. So we'll keep to that definition, but maybe this person went with atomic fields. That's the definition which was maybe 35, 40 years back. As a student, that's the definition that was taught to us. But now I haven't seen it anywhere. All I see is that there are no repeating data in a field. And repeating data doesn't mean 111, 111. That's not repeating type of data, right? So in an address field, nothing repeats. A house number is not the same as street, is not the same as postal code, is not the same as town. So there's nothing repeating in it. But yes, favorite sites, there is a field called favorite sites, and each comma, each of them is a site address. That's repeating data. Okay. So, but I didn't change it. I didn't want to because it was too much work. Then there is a phone number stuck to character 13, and maybe the phone number is in a certain format with dashes, and that's the character, and again didn't change it. And the primary field. So is the table in the first normal form? Yes, it has a primary key. Is it in the second normal form? Yes, it is, because there is the primary key is a single field. When you only have a single field as the primary key, it automatically is also in the second normal form by default, because of the definition of second normal form, which we'll come to today. So this table is already in the first normal form, has a primary key, and there is no repeating group of data in any field. Okay. Now I have the drop table command here, which I have commented out because I drop my database even before I begin. And just again, I don't know, I may have problems again. I'll just change it to 2 for section 2. It's not creating. I can delete the previous ones for whatever reason. Maybe that particular sector is bad or something, right? Now, keep in mind, you may not be allowed to drop a database if you're working on a server. Dropping database is not common. You may not have that, privilege to do that. The privileges are granted by the DBA, the database administrator. So he may or she may decide, no, you can drop databases for whatever reason. Maybe in the organization, you are not at a position where you can drop databases. It's not under your hands. So you may not have it, but you may have the privilege to drop a table. And therefore, when you cannot drop databases, but you want to drop a table, you should know the command of how to drop a table. Okay, so I keep them so that you have it in mind that, oh, the database can be dropped. Not necessarily, not in the real world. In the real world, you don't drop databases on the go like we do on the fly every time. So that's the first table. All information about players is in that table. Make sense? Everything about players. So it's in the first normal form. Let's look at table number 2. This is about teams. Every team has a primary key, which is called team number. And another thing that I would like you to bring your attention to is notice the convention that is used for field names. They're using the Java naming convention, the camel case naming convention. I have stuck to underscore. But in MySQL, in all databases, there are two conventions. You can use the underscore or you can use the camel case conventions. How is your Java going, guys? You have Java in this course too, in this semester too. Going okay? I know it's a little tough, but that's much, much tougher than this. And I did teach it till last semester. And then I said, not this semester, I'll take a break. I'm teaching Python this semester. Anyway, so this is the camel case naming convention. You've seen it in Java. And it is also, you can also use it in databases. So whoever this programmer has this convention, I've been sticking with the underscore because I see that more. Anyway, so here it is. The team number is the primary key. There is a captain of the team. But remember, this captain is actually a player. The captain has to be a player. So it is a foreign key which is drawing its value from the player number in the other table. I could have called it player number here, but captain just makes more sense. So the team has a captain and every team will have one captain, and that captain has to be a player. So his information must be present in the player table. So captain is a foreign key which is drawing its value from the player number field of the table players. And I'm using InnoDB as my engine to see that these keys are, foreign keys are enforced. They are not enforced in MyISAM. Keep that in mind. And then there is a division. I'm not very sure of what the division means. And I think this is more of the, it's not from, it's a US, it's all postal codes are kind of US and so are phone numbers. But I don't know, as I've never played games here either. So I'm not sure what division means. Maybe something like a league, I don't know. But league is different from a division. But there it is, there was a division there. I didn't want to touch it. I just left it alone. The third one is about matches. So which matches have been played till date? So, okay, so what was the match number? Again, it is an unsigned primary key. Every match has a unique number because matches may be played on the same date, so date cannot work. Team numbers, a team can play many matches as we know, so team number cannot work as a primary key. Player number, again, cannot work as a primary key. Was it one lost? We'll see how the data is, what is in, how many were won and how many were lost by that particular team. So look at the matches. This match was played by this team, and what is the player number doing here? What is the use of player number? Let's look at the data of the, oh God, doesn't make a lot of sense, but oh, this player played in it. Okay. That's kind of an odd to keep, but again, nothing that I can do or say about it. So which match, which team played it, which was the player in that particular team, and how many were won and how many were lost. Again, the primary key is nothing else but match number. You could have done it an auto increment also. We didn't have to kind of make it an int. We could have said int unsigned auto increment. But again, as I said, this is a database. This is something that's another programmer has written. I just took it as per se. Because match numbers 1, 2, 3, 4 is kind of common. But maybe they want to do their match numbers as match 1 and add something to it, the division or the league number or whatever. The primary key is the match number. The player number definitely has to pull its value from the player number of the table players. And the team number has to pull its value from the team number of the team. So the foreign keys are quite obvious. You can't have a team number that does not exist. You cannot have a player number that does not exist. So those are foreign keys. Let's look at the fourth table. Definitely there are penalties that always are done by players when they play. So which player has paid what amount on what date is what is in the penalties table. And I see an amount of 7,2. And I'm not sure, is the penalty so high? I have no clue. Again, I didn't touch it, but I have no clue if payments are so high. So what is the payment number? Again, it is the key of this particular table. The player number, of course, makes sense here. This player on this date paid this much amount, so he has a penalty against him. And a player can have more than one penalty. So player number cannot act as a primary key. Payment date cannot act as a primary key. Amount cannot act as a primary key. So we had to add another field, which we called payment number, and it is an auto increment, could have been an auto increment. Again, it was not created as an auto increment. I didn't touch it. Tables were already created. I didn't want to make changes to it because it was so much work. And of course, the player number has to be an existing player, and therefore it is referencing its value from the table players. The last table is something which is new because we have a composite primary key. So I'm going to now discuss this with you. This is the first time you have seen a composite primary key. Let me explain what this table is about and then argue why didn't I choose something else as the primary key. This is about committee members. A player is could be or could be not. He may or he may not decide to be a member of a particular committee, right? So there are different committees, and a player can say, oh, I want to be a member of this committee or this committee or this committee. The restriction is he can be a member of only one committee at a particular time. So he may be a member of committee 1, say in January to March, and then he goes to another committee from, say, May to September, goes to another committee from, say, December to March of next year. Like you guys, you do a particular semester from month 1 to month 4, then another from month 5 to month 8, and then from another from so on. So that's the same kind of rule here. It is saying that a player can be a member of more than one committees. He could have been, but at one particular time, presently, at a particular time, he can only be a member of one committee. So if player 1 was a committee member of C1 last August, his information will be in this table. He is a member this right now of some other committee. It will also, this information will be also in this table. So player number cannot act as a primary key because a player can be a committee member of different committees at different times. So player number cannot be a primary key. I could have created an auto increment, but I just didn't want to in this one because I wanted to work with the composite key. Begin date. When did he begin to be a member of that committee? Right? So the begin date is important. Not null also. The end date. When did he finish up on that committee? Now, why have I said it's not null? Why have not put that restriction? Currently, if he's a member of a committee, there is no end date. So I'll put null to say, oh, he's still in that committee. That will tell me members who are still active. Okay. And the position he holds. Now, position is a reserved word. So I'm just going to do a control F. We can do this for sure. I'll do a find and replace. And I'll replace position by position held or something. Oops. I don't like to use reserved words. MySQL doesn't mind. So what position is he holding? Is he is he a bursary member? Is he a chairman? Is he a secretary? It could be any position. So that's what this position held is. Now, this does not have any other field. Now you tell me which of these fields can act as a primary key. Of course, not player number, because as I said, a player can be a committee member of different committees at different times. So his information can be at more than one time in the table. Begin date. I could start on this, all of you start on the same date in a particular semester. So begin date doesn't make sense to be a primary key. End date, again, doesn't seem to be, because one, it doesn't have the not null one. And again, all of you end on the same date. Your semester ends on the same date. Can make it a primary key, is not unique. Position held, again, is not unique. Why? Because you will see that I may be holding a manager position today, and tomorrow you can be a manager. So the position held can have repetition of a particular position. So instead of creating an auto increment or a field that was just an int like I did in all other tables, the combination of these two is a unique, not null combination. Why? Let's look at the data. I want to show you the data of this field. See, player number 2 was the chairman of a particular committee from January 1990 to December of 1992. He again became a member, just a member, not the chairman. He again became a member of a committee from 94, and he's still a member. Therefore, you see null here. So notice how 2 is occurring twice. So I can make that combination. But this combination, the begin date and the player number combination is always unique. Why? Because a player cannot be the member of a committee on the same begin date, because the restriction is he can only be member of one committee. So he cannot join two committees together on the same day. He has to come out, he has to finish being a member of a committee and then start a new one. So this combination is unique. Nowhere do you see a repetition, though you see repetitions of player numbers, but this combination is unique. And this uniqueness is coming from this restriction that has been placed. A player can be a member of only one committee at a time, but can hold different positions at different times. Which means the key, the primary key, the combination of the player number and the begin date is unique and not null for every record. Which means what? You can make it the primary key. This combination is unique because he can be a member of only one committee at a time. So you cannot begin semester 1 and semester 2 on the same date. Can you be a student of semester 1 and semester 2 at the same time? No, you cannot. Same with these players. They can only join one committee at a time. If they join one committee at a time, the begin date will have to differ if they join another committee. They have to kind of resign from the first committee and go into the second committee. Like you guys, you only have a semester. You could be doing a course from another semester, but you are only designated a semester number. In your records, you cannot have, oh, Sunshine joined semester 1 on May 1st, and she also joined semester 2 on May 1st. Cannot happen. It cannot happen. So same with these guys. So this combination is unique, and which means, what are you seeing here? You are seeing a composite. This is called a composite primary key. So your composite primary key is this. And you don't write primary key in front of these two fields. You have to write it as a separate statement because a table can only have a primary key. So if you write primary key here in front of this field and in front of this field, it says, oh, two fields are primary. And that cannot happen. Whenever there is a composite primary key, you always have to write it this way. You have to write it as a separate statement. So a composite primary key exists. As soon as there is a composite primary key, we talk about the second normal form, right? Now a table with a single primary key, a table which is in 1F, a 1F table means first normal form table with a single field primary key is by default in second normal form. I've been saying that all the way because the second normal form only comes into action when you have a composite primary key. If it is a single field, then it's automatically in the second normal form. Now, when is a table in the second normal form? Let's define that. A table is said to be in second normal form. Oops. Let's define. If and only if, condition number 1, it is in first normal form, which it is. This table is in first normal form. That's a requirement. It has to be in the first normal form before it can be in the second normal form. And 2, every non-key field. What do you mean by every non-key field? A field that is not a part of the key. So here, end date is not a part of the key. Position held is not a part of the key. Every non-key field is fully, completely, oops, this needs a, is fully or completely, whatever you would like to say it, dependent on the composite primary key. It's not dependent on part of it. It's dependent fully, right? It's fully dependent on the key, not on a part of it. Here where it comes, part of it. Why part? Because there are two. It could be only dependent on this part. It could only be dependent on this part. It cannot be. It is fully dependent on the composite primary key, not on part of it. Right now you will say, can you give us an example of where I can find this? This one is in second normal form. It is already in the first normal form, has a primary key, all fields, there is no repeating data. Does the end date only depend on player number? No. Does the end date only depend upon begin date? No. It depends upon this player, and this player began on this, so the end date depends. So a student who started semester 2 and his begin date was May will end in August. A student who started semester 3 in January will end in March. So it is dependent on the combination. And so is the position held. Position held depends, because position held could be anything. I could be manager one day, I could be a member the other day, I could be a bursary, a secretary the third day, and so on. So again, the position that you're holding does not only depend upon the player, it depends upon the committee you belong to, and that committee is which player and the begin date together. If for whatever stupid reason I add player name here, which I shouldn't. Suppose I add player name here. So I'm going to pick up the player name from here, whatever it was. I say I will add this field also, so that I also know the name of the player. I add this field just for the heck of it. Now here is an example that is not dependent upon the composite key. Player name is only dependent upon player number. It's not dependent upon the begin date. So why would you put so that is a bad design principle. Why would you put the player name here? You'll say, oh, it's easy. It's easy to see the name of the player in the same table. But that's not what we are looking for in designing a database. When we design tables, we have to keep some rules in mind. And the rules were made keeping in mind data integrity, searching time, updating time, deleting time, and so on. So if the player name occurs at two places, that means anytime I want to change the player name, I have to be careful that I change it in the table players, and I also change it in my table committees. Where lies the need? Right? Where lies the need to do that? Where lies the need of putting the player name in this table? There is no need. Duplication of data is never recommended until it's really, really required for a particular reason or reasons. It is not recommended. Why? Because I'm updating table 1 and I still have to write between the two statements, update table 1, update table 2, if some user comes and picks up the data from the table 1, the name is different here, and picks up data from table 2, the name is different here. And you will say, oh, I can lock the table. Yes, you can lock the tables before you update them, then nobody can access them. That's fine, that can work. But why would you go to all that extra work when you do not need the name in this table? If player name was in this table, then this table is not in the second normal form, because player name is only dependent upon player number, not on the begin date. So this is an example. If player name was a part of this table just for the heck of it, you didn't design the table well, then this table is not in the second normal form. So you can, so the irrelevant field, the redundant or irrelevant player name breaks this rule. So what should you do? Remove it. So it should not be a part of the table. And logically think about it. Do you even need it here? You don't even need it here. It makes no sense to put the player number here. Yeah, maybe for ease of reading data, that's all it will give you, ease of reading data, because numbers are numbers, names mean better. I recognize you by names, not by your student numbers. So just because of that ease, will I put on stake data integrity? Unnecessary updating of data in more than one tables? Why would I do that? So you should not have this player number in this table. But if it was there, then this table was not in the second normal form. Remove it, and then it is now in the second normal form. Every non-key field, what are your non-key fields? There are two non-key fields. Every non-key field must be completely dependent on the primary key, not part of it. So end date depends on the combination. The position depends upon the combination. So this table is in second normal form, right? So you've seen the second normal form in week 12 now. So that's your second design rule. There is one more to go, the third normal form. If I cannot show it to you in an example, I'll do an example next week. Then here are the insert statements about teams and about penalties and about committee members. So give it a go, give it a run first. Run it so that if we've made any, I haven't hopefully made any mistake, but here are the tables. So that's information about players. That's information about teams. There are only 3 teams. You could have had 10 teams, but there are only 3 teams with captains 6, 27, 112. I have no clue who they are. And notice, therefore, auto increment has not been used because these are not auto increment. They have different numbers, 2, 6, 8, 7, and so on. But I can always get the name of the player. Then comes matches. Which match was played by which team? The player was in this team. Who won it? How many did they win and how many did they lose? I can understand the use of player number in this table. I understand the use of match number. I understand the use of the team played it. Maybe this is the captain at that time, could be. Instead of calling it player number, it could be the captain. How many matches were won and how many matches were lost? So maybe this player number is the captain. So it's not very clear. And that's my guess. Then here are people who paid penalties. Player number 6 has paid a penalty. 44 has paid it twice. 27 has paid it. 44 has paid it thrice. 27 has paid it twice. So here are some penalties and they don't go more than $100. So 7,2 was not a good. I thought it was too much. You can reduce it if you like to 5,2 or 6,2. I don't see anything greater than $100 here. So 7 is too big for 100, right? 5,2 is more than enough. But anyway, and this is the committee members. Right, so player number 2 was a chairman in 90 to 92, and now he's a common member in 94 is still a member. Again, 6 was a member, then he was also or she was also a treasurer, and then now he or she is a chairman. So he's still the chairman, 93 to whatever. The null is saying till whatever. So the tables are ready. All now we need to do is do a reverse engineer of it, create an ERD, take a break, come back, and then do our DB Sports 2 is what I called it. There it is. Once your ERD is ready, and we'll kind of move them so that we can see them more clearly. And also, if something is related to more than one table, it's easy to see if you put them between the 2 tables. And now, just because I've drawn it, you will see that there is something new you're seeing here. You were seeing dashed lines till now, and now you're also seeing like a solid line. I kind of read about it. It said relationship weak are dashed, are strong are bold lines, and relationships that are strong are dashed lines. Now, weak and strong relationships is something that is not in your course, and I don't know a lot about it, but there is a difference between relationships being strong and weak in the sense of how much they're used, for example, is my sense. So that's what the difference is, but I'm not stressing it because I'm not completely experienced to explain the difference between weak relationship and strong relationships. But if you read it, Google it, the dashed lines are strong relationships and the solid lines are weak. You would think it would be the opposite, but that's what it said. But I cannot explain what they are because I just saw them yesterday. But on the weekend, I'll read about it. And if I have something to tell you, I will tell you next week. But
I just did it yesterday with the other section, and I said, oh, there are weak and strong relationships. We Googled it, a student Googled it for me, but I'm not aware of the difference. Now notice something here, guys. Look at this diagram. You notice keys, the key shape. There is a yellow key shape there. There is a yellow and a red key shape here. The key shape says it is a composite primary key. So when you see keys in front of two of them, it means it is a composite primary key. But one of this is red also. That means the pair number is a foreign key. Right? Here you see a primary key, a red diamond. Red diamond means a foreign key. So the key symbol, though we call it a foreign key, the key symbol is not necessarily for the foreign key. A diamond is also a foreign key. The key symbol is only for primary. The symbol itself is only for primary. And if it is yellow, it is a primary key only. If it is red, then it is a primary key and foreign. So you see that here we have this symbol twice. Why? Because it is a composite primary. Making one red doesn't say, oh, this is not the primary key. The key symbol says it is a primary key. So when you draw the legend for me, please see that you draw the key symbol and say that says it is a key. The colors are different. The yellow color says it is a primary key. The red color says it is a primary and a foreign. The diamond, just a field. A blue diamond, not null field. A red diamond, a foreign key. So the symbol is diamond, it is a foreign key. And if it has no colors, then it is just a normal field which can be. So if there is no legend, there are no marks. It's as simple as that. Right? And please, I'm stressing it again. There is a symbol, there is a color, and there is a relationship. And all these three must be in the legend. And the relationship is shown through one-to-many. So you tell me, oh, is there a one-to-one or is there a one-to-many? And you will tell me what does infinity mean. I don't know what does infinity mean. So you say this dash, dash, dash with 1 to infinity is a relationship that shows a one-to-many relationship between the two connected fields in the two tables. According to this diagram, pair number here is connected to pair number. So you have to be very clear in your legend. And if there is no clarity, or there is, you will lose marks if there is, the clarity is missing. Of course, you get a 0 if there is no legend. I don't want a printout of this. I know you can take a printout and give it to me. Okay? So take a colored printout if you want, take a black and white, and then use your own colors. You have red pens, you have blue pens, you have black pens. Everybody has them. You have highlighters. You know what I mean? And do whatever. Draw it by hand, use the workbench, use any other tool, whatever you like, but it needs to have a legend. So we'll stop here. We'll take a break of 20 minutes. You can have something to eat, come back, and then we will start doing our questions. And we may not be able to finish them, but that's okay. That's fine. There are only 4 of them, but again, there are so many ways of doing the same thing. So take a break and we'll start at 9:40.
So we did our, I'm sorry, it's small, but I don't know, I can't make it any bigger.
Did you take a print or did you put it in paint and?
No, I just, in the workbench,
Mhm.
I just click Control P to print it, and then I say save as PDF. So that's the PDF. So
Okay, so that's okay when it says one to many, but you were telling me what the dash line is.
okay.
So the dash is missing, right? So the
Strong
dash line is the relationship between the two connected fields. And there is where it says it's a one-to-many relationship.
Okay.
Now what's that, the black one?
Yeah. So the blue diamond is not null,
Mhm.
normal field. And then this field is an lollipop driver, not one foreign key.
What is that? Okay, this one.
Those two only.
What about a primary key there?
Just box, black box.
So is there no composite primary key? I think one.
This one is it's a primary key and foreign key, and both together make composite primary key. So in the workbench, they're only printed as red keys. So
Yeah, so they're primary and they're red.
yeah, primary key and foreign key.
So you haven't kind of taken color into consideration, you just concentrated on this one. So it's
Yeah,
okay.
I tried to make simple because I only had the black pen one, and I used a pencil.
Okay, so the only thing that's missing is the relationship.
Okay, I write this one.
The rest is okay.
So I write just this is
So you
conservation
can just make a
dash line.
dash line, say 1 on one side and infinity on the other side, and say the relationship, the one-to-many relationship between the two connected fields.
Okay, and all of them are one to many, right? Because
Now that I can tell you, that answer I can give you. You have to figure it out
okay,
yourself.
I tried to understand this
Yes, okay.
from the internet as well,
Mhm.
but the only thing that's confusing me is this part. Because since it's only one primary key, then it has to be one because it doesn't exist multiple times.
Yeah,
So every primary key will be one.
yeah, but this is a composite primary key. That's
So
all
I
it
could
is
have
saying.
many because it is composite, right?
No, composite means it's not a single field, it's more than one field make up a primary key.
Right.
That's what a composite primary key means. Now the relationship, I can't even see to which field was this connected. This part was connected to the part number
Yeah.
only, right?
Right.
So all it is saying is that this part number can occur more than once in this table.
Yeah, the point is, it really occurs more than once.
Yeah?
But the point that I don't understand is how does it occur more than once if this is also a
Primary key, but it
Yeah.
is alone not a primary key. The combination
that's
is the
why.
primary key. That's why.
Mhm. Okay,
That's
so
what
it's
I'm
one
trying to
many.
say. The one-to-many relationship is saying this part can occur many times here, which
Right.
is true.
Mhm.
But that's alone is not a primary key. The combination is a primary key.
Got it.
That has to be unique. Okay?
Mhm. So that's fine.
Yes, that's right. So
And
you
also-
double check that the relationships are correct. I can give you that answer. But yes, this is not saying, I mean, you are saying, oh, this is a primary key, how can it be many here? All it is saying is this part number can occur many times in this table.
Right. Since
But-
the combination itself is.
Yeah, but primary.
Okay, and I also wrote at the back of the fields which are not null, which are for a primary, in case this key is not.
No, that's okay,
there,
yeah.
so-
But the only thing is missing is the relationship. So draw a dash line, put 1 to infinity and say, this is a one-to-many relationship between the two connected fields in the two tables.
Okay.
Because your fields are connected, right?
Okay.
Okay?
Okay. Okay, I just added them. I added the. No, okay.
Okay, you sort. You double check that's strong and right, right? Okay.
Yeah, the.
Yeah, and you can just add between the two connected fields in the two tables. See, it's showing me that this field is connected to this field, right?
Yeah, this quotation for the.
Yeah, so you can say one-to-many strong relationship between the connected fields in the two tables,
Okay.
right?
Okay.
Okay. Okay, but guys, let's get back to this now. As I said, may not be able to finish it, but that's okay. As long as we do it, it's not a big deal. Okay, so now that you have the tables and you've seen a composite primary key for the first time, keep in mind a composite primary key means the combination is unique, right? And one of those fields could be connected to another table, and that's perfectly fine. But that doesn't mean there can't exist a one-to-many relationship between the two. So for example, let's see if I can see an example here. This is, see here itself here. The primary key is composite. You have a player number and begin date as the composite primary key, but there is a one-to-many relationship between the two tables. You'll say, how can the player number be many? Because it's a primary key. Player number can be many. It's the combination which cannot be repeated. Okay. So if you see this, it doesn't mean that, oh, many means the primary key has many instances. It's the player number has many instances. The combination itself does not have the same, has unique instances. Okay. So be careful about that also in your assignment, because I just noticed that Jed told it was there in the assignment also. Okay, so let's start to answer this. Question number 1 says, find the name and the initials of the players for whom at least one penalty has been paid. So this player has paid a penalty. So I've said inner join, I've said outer join, I've said a subquery. Why I've said an outer join? Because not all players have paid penalty. So it's here and not here kind of stuff. Okay. Okay, so let's start with the inner join, with the normal one. We want to select, and I'll give you the field names just so that you don't have to keep looking, but the name and the initials of the player. The name of the player is player name. And since a player may have more than one penalties, I'll write it once and then we'll change. Then I'll show you, okay? The player name, oops, sorry, N is capital. And you don't use your own conventions, you have to be careful, okay? And the initials, the field is called initials. So if you like, instead of this player name, you could give it a name like player name. It's perfectly fine, single or double, more than one word. And the second field is initials, and it is called initials. Right now it says for whom at least one penalty has been paid. So definitely the name is coming. We know from where the name is coming. It's coming from the table players. You know about that. And the penalties is coming. I'll use inner join to start with, and then the penalties is coming from the penalties table. Right, and now comes the joining condition. The players has a player number and the penalties has a player number. So let's look, are they called the same? The player number in table players is called table players, and it is called player number also in penalties. Okay, so we can do it a few ways. We can call this players PL for players. We can call penalties as P, and we can write an on, which we are saying PL dot player number. Oh, it's not very helpful. There it is equal to P dot player number. Right, that's your joining condition. So these are people who have paid penalties. Right, let's try it once and then I'll do the various ways that we can do it. And remember, there were two who had paid it thrice, and there was another one who has, and you'll see them. So if you kind of look at the answer, Collins has paid twice, Baker has paid it 3 times, and the others have only paid it once. If nothing is asked, if it says, oh, show it only once or whatever, find, and all it says is find the name and initial of the players. So the distinct will only show it to you once. You can also do it by group by, if you remember group by, but it's not so intuitive. But instead of distinct, you can also use group by. Instead of using the distinct word here, you can say group by player number. So it's not as intuitive. Distinct is very intuitive. And since the player number is the unique field in the players table, I'll group by PL player number. And they are same anyway. You want to see all of them? Sure, leave it without distinct. But all you're interested is in who has paid a penalty. The question is not saying, show them more than once. But again, I will be more clear in my question when I give it for an assignment. Here, if you want, you can make it more clear. Find the name and of whom at least one, and you can say show it only once. You can add it to the question if you like. You can just go and add it once here and say show each player once. So that way we've kind of taken care of it. Which means you will use distinct. Oops, sorry, that was in caps, but that's okay.
Too lazy to kind of change it now. Right, so when I say only once, automatically it means you will use distinct. And group by is another way of doing it, but not very intuitive. But you can do it. Now, we all know that we can do many more ways. And hopefully you're doing it or working on it. Instead of on, you can say using. If the field name is same, you can say using. Or if the field name is same, you can also say natural join. They all mean the same thing. And then, of course, you don't need using. Right? And we've just done commas. When we do commas, then we cannot use on. So comma is kind of, I don't know. If you do a comma, the only thing you have to remember is don't forget your condition, but it has to be done using where. There. So inner join can be written in many ways. You can use the word inner join, you can use the word natural join, you can use on with inner join, you can use using with inner join, you can use comma and use where, and you may do any that you like. Right? And I've done distinct everywhere because that's what the question said. If it was not asked, I wouldn't do it. Okay, now let's do it using outer join. Okay, now let's think about it. We have a table players. All information about players is in one table, right? And all information about who has paid a penalty is in another table. And I'm only interested in people who have paid a penalty. So if I'm going to do an outer join, I just want to pick up people who are in the penalties table. Not, maybe it's not shorter or whatever, but those are the people of interest. So let's take that as the master table and then look for their name in the other table, right? Because that's the question. The question says, who paid a penalty? From where is that information coming? From the penalties table. So let's make that as our major or the master table. So if I make that as the master table, which means penalties is the master table, we basically have to do a right outer join because it's on the right hand side. And again, we'll kind of go one by one. I'll do a star first to see how they are joined. What do I have? And everybody, every player in the penalties table will find a partner in the PL table because he is a player. Right? They will all find a partner. So there won't be any extra records. So let's look what the result is. We already know the result, so we'll look if we get it. So there it is. 6, 44, 27, 104, 44, 8. They all found partners. So I don't have to kind of remove any records. Why? Because I picked up the penalty table as my major table. And I said, oh, you've paid a penalty. What's your name? You could have done it the opposite way, but that's definitely less efficient. Oops. And why am I going to say less efficient? Because I'll show you why less efficient. So now this is working. You can remove the star. Again, you can put the distinct back. And your results will be the same in both of them. I'm showing you both inner join and outer join to prove to you that those are the 5 people who have paid penalties. Doesn't tell me how many times, but that's okay. If I needed to know how many times, I would have done a group by and having. Okay? So they are both right. Now to show you a less efficient way, just so that you know, you can pick this up, put it here, use a left outer join and think of what you are doing. You are picking up every player and saying, did you do a penalty? Do you have a penalty? Like, that's stupid. That's asking every player a question that can be answered in a better way. You have a table that has the penalties being paid. So how to prove that this is less efficient? Do the same thing again. Put a star here, comment this out and run it. And you will notice that there will be more records in this table. And there are extra records. I don't want these. I only want people who have paid a penalty. So the result itself shows you that the table is bigger and you'll have to put a search criteria on it to remove the extra records. So definitely it is less efficient. Make sense? Right? So why is it less efficient? One, because the table is bigger. You have more records. Because you're checking every player. And you will also have to filter it. So how do I filter the records? I have to put a where condition because I want to only keep these ones where the payment number is not null. Those are people who paid it. So we'll have to add a where condition also, where the payment number is not null. So definitely by virtue of looking at itself, you can see that, oh, this will take more time. So one, because more records, because every player is being checked and will have to filter the records also. So this is less efficient. So now again, check it, remove the star and see, you will have the same result, of course. So again, same 5 people, but I don't know if we can see the time. No, time is not very helpful to us because they're less than a second. So it says 0 second. But definitely you saw that I had more records and I have an extra where condition. So whenever you are saying, oh, ask everybody, though it is not required, and then you're saying now remove, definitely it will take more time. So it can be done using an outer join for sure. One is more efficient than the other. So this is more efficient. Why? Because you're only checking the players who have a penalty. Definitely. I mean, you're only answering the question. You're not saying, oh, from the whole set, I'll choose it. Penalty. Make sense? So you should start to, and your programmers, you should start to think which is what more efficient than the other. Okay, let's do the subquery now. The subquery what? Find out people who have a penalty, then find out their name and initials. So how do I find out people who have penalty? From the penalty table, select select player number. From the penalties table. These guys have made a penalty. What was it called? Table penalties. Yeah, it was called table penalties. All these players have made a penalty. Right now, a player may have made more than one penalty. We have seen that. So you can say select distinct player number. If the engine is not already kind of removing it, this way at least you're saying, I only want to see the player number once. So that the set is smaller. If you use distinct, will create a smaller list, right? It will create a smaller list. So, and therefore searching time will reduce. And now 2, we want to select, which we can kind of copy from here, the player name and the initials from the table. Where this player number is in this select clause. Oops. Do I need distinct here? So I pick up We don't even need distinct here. Why? Because this table player's key is player number. So each player number is only occurring once. I don't even need distinct. So the first player is picked up. Are you in this list? Yes. What's your name? The second player is picked up. What are you in this list? Yes. What's your name? Kind of stuff. And distinct will create a smaller list, but maybe the engine stops when it finds the first search. We don't know how the engine works. If I don't use distinct and it is a longer list, so suppose 666 is occurring more than once, 3 times, maybe when it finds it, it stops. If the engine stops searching, so we don't know how the database engine depends on, we'll have to read it up. Stops the searching at first find, then distinct is not required. So you may have a longer list, but as soon as it says, oh, I've got it, it doesn't search the rest. So then distinct will not be much helpful because it stops at the first find. If it finds it and still searches it, which is very silly, I've already found my answer and I'm still saying, oh, maybe there's another of it. Doesn't make sense, right? So if a player has made more than one penalty, he will occur more than, or she will occur more than once in the list. But if the engine stops searching at first find, then putting distinct here is not very useful. But who knows how it works, how the engine works. So from our side, we've made it efficient. We've said only choose the number once. It makes sense. Only choose the number once. And I don't need a distinct here. Why? Because player number is basically, player number is unique. It's the primary key and it will only occur once in this table. If it only occur once, it will only have a name and a initial. So this subquery must also work the same way. 5 people and their names and their initials. Right? So we are back to we've again started doing more than one things. Okay, so who have paid no penalties? As soon as there is a no penalty, it can't be an inner join. It has to be an outer join. You can do no's with inner joins because inner joins are always friends. And whenever there is a no, that means you're here and not here kind of stuff. Okay, so now we've already written the outer join. So we'll copy the outer joins from there. And then we'll see what is more efficient and what is less efficient. It may be different, right? So these people have paid no penalties. Now, if people have made no penalties, my major table should be my players table because all the names are there. The penalties table is showing me who made a penalty. I want who did not make a penalty. So I can't use penalties as my major table because this is who made a penalty. So this will not answer my question at all. Remember when we looked at it, we got only people who had it. So this is not a solution at all. It's not even a solution because this is people who have paid a penalty. So this is the only solution. Pick up everybody from the players, do an outer join with the penalties, but we don't know which ones to select. So let's look at what we have. Let's put a star. Instead of not null, it will be is null. Just for your information. Why? Because it's the opposite. I want to pick up people who have not made a penalty. So try it first. Put a star here. Comment out the rest. And now just pick this up and run it. Okay, so what happened? Every player in the player table is saying hello to people in the penalty table. And whoever doesn't find a partner has not paid a penalty. And that's what we want. People who haven't paid a penalty, have paid no penalties. So definitely here my major table is my player table. Because I want to say you are here, but you are not there. So there is no question of being another solution. There is no other solution. You have to start from the player table and you want to pick up these ones where payment number is null. So where payment number is null, you want to pick up. So let's go and where payment number is null. So it will only pick up where the payment number is null. And here payment number is null everywhere here. So these are the people who have not paid a penalty. And we only want their names, and we don't want distinct. There won't be, we don't need distinct again, because when they are joined, there is no partner there. There is no partner there. So if there is no partner, of course, you can't see them more than once. So these guys have not paid a penalty. So guys, you have to be careful. Where do I need distinct? Where don't I need distinct? If you're writing distinct when it's not even required, it's not even making sense, that's again redundant code. Right? That's again redundant code. And it again is less efficient. Why? When it says distinct, it does it and then it checks. Oh, are there duplicates? I have to remove duplicates. But there are no duplicates here. Right? There are no duplicates here. So the player is picked up. It says, do I have a partner? No. Okay. Spit out the name. Another player is picked up. Do I have a partner? Yes. Don't spit out. So take your players table in which every player number only occurs once. It's a primary key. So I don't need distinct. Look for a partner in the penalties table. If you don't find a partner, spit it out. There is no other solution. I can't do any other join. This is the only way I can do an outer join. Right? So sometimes you may not have more than one outer join and say, oh, this is more efficient and this is less efficient, because it depends upon the question. Now, can I do it using a subquery? Why not? Because if I can do who paid a penalty, I can do the opposite. So the subquery that you wrote here, you can copy it here. Let's try to put it the same subquery here. The only difference is what? We have to pick up those players who are not in. Who are not in this list. So pick up the name and the initials of those players where the player number is not in the other table. So instead of being in the other table, they are not in the other table. Again, distinct will create a smaller list. And I'm again assuming that if the engine doesn't but in not in, it has to search the whole list, because not in means you're not in the whole list. So distinct definitely will create a smaller list. Irrespective of what, engine cannot stop at the first find. Engine has to search the whole list. Keep in mind, the engine has to search the whole list. Excuse me. When I say engine, I mean the database engine. Definitely this is better in terms of, oh, I should put a distinct, because I can't get an answer till I ask each one of you, do you have a pen? Do you have a pen? Do you have a pen? I have to ask everybody. Only then will I know if anybody has a pen. Whereas if I say, if it was the opposite, I'm looking for a pen and I say, do you have a pen? And she says yes. Why will I ask the others? You know what I mean? So if I'm searching for something or if I'm not searching for something, there are two different things. So here, engine has to search the complete list. So please make it shorter, and distinct will make it shorter. So there are people who have paid no penalties. Okay, let's go to the next one. It says, find the name and initials of the players for whom at least 2 penalties have been paid. So we've paid 2 penalties at least. So you can do it using, so we've just said 2 penalties have been paid. So you can pick up the joins that we did in the first one. Just pick up one of them. I mean, if one will work, every one of them will work. Okay, but we have to do something to it. Okay. Okay, so people have, oops, what did I do? Let's see. Okay, so these are people who have paid penalties using an inner join. I'm going to pick up the outer join also, the efficient one, just because it makes no sense. You've already seen the less efficient and the more efficient. These have people who have made penalties. We already have answers to them. We just have to add a condition. And these have people who have paid a penalty. So all I've done is I've copied the answer from 1A into 1C. Only one of them. From the inner join, I have taken one. From the outer join, I have taken the more efficient one. And the subquery, I've taken, there was only one. Now I have to add a condition to it. It says at least 2 penalties have been made. So if at least 2 have been made, I can't use distinct because I have to do a counting. That's your first thing. You cannot use distinct because you have to count. Now, how do you count? Group them up and see if the count is greater than 2. Right? Group them up and see if the count is greater than 2. So group it up. And how will you group up? You tell me, group up by what? How should you group up? By the player number. Because player number is unique. So not by name. Maybe 2 persons are called Anju Chawla, 2 players are called Anju Chawla. So don't group by player name. Group by the player number. Always try to use the primary key because it is unique. So if player 6 has made more than 2 penalties or player 7, I'm not grouping them by name. I don't know if the names are same. I don't even care. Like, why should I go and search? Are 2 people called the same? But the probability that 2 players have the same name exists. It can happen, right? It can happen that 2 players have the same name. So group them by player name and having count of this grouping of the PL player number should be greater than or equal to 2. These are people who have made 2 or more penalties. Remember, Collins and somebody else. One had 2, one had 3. The all rest had only done once. So I don't need distinct now. I don't need distinct now. Because distinct, how will I group them then? So I group them up by player number and I check, do you have your count greater than or equal to 2? And there were 2 persons. There were 2 of them. There it is. Collins and Baker. Collins had done 2 penalties and Baker had done 3 penalties. The rest of them had only done 1. They don't come in the table. Make sense? So I added the group by having so that you don't forget your advanced SQL that you did after the midterm. So group is to having as where is to from. So you're laying a condition on the grouping. You're saying make groups of players now, numbers, not names. And then if the count is greater than 2 in a group, give me that group. And again, I'm using player number because player numbers are unique. I'm not using names because it may happen that Anju Chawla has made a penalty, another Anju Chawla has made a penalty. You group them up, it becomes 2 and you give me, oh, Anju Chawla has made 2. And there are 2 different Anju Chawlas playing the game. Okay, so group by player number. Don't group by the unique number, not by name, which may be duplicate. I don't know, maybe. So why should we even think about it? Or even replicates, who knows? Make sense? So don't put distinct, otherwise you won't have an answer. So count, group them and then count them. Now in this one, we are checking the players who have made a penalty. Same thing, remove the distinct, add the condition, and it should work. And why should I take the less efficient one? I can take the less efficient, but why should I do the less efficient one? So I said, okay, these guys have made penalties. From the penalties, I'll try to find a match. And this, Yep, 6 will find a match, 6 will again find a match. So they will come twice, yep. And now the grouping by. Who are we grouping it by? We are grouping it by player number anyway. So there is, I mean, whether you use the P player number or whether you use the PL player number, does it make a difference? Joining condition is your player number should be same. No, it doesn't make a difference. I mean, logically, the P player number is what you're grouping by, but it doesn't make a difference. I must again have the same result. Sometimes grouping by is, you have to think about it twice. Collins and Baker. Right? It was already working. It was already saying these people have made a penalty. All I'm adding is have only those names that have made 2 or more penalties. So I remove the distinct, I group them up, and I say count is greater or equal to 2. Right? And I just chose the more efficient one just for the simple reason that it makes no sense. I mean, you can copy the less efficient one and add the same condition. But I'm just showing you the answer that is okay. Okay, now let's look at this one. These players are here and their player numbers are here. They're only occurring once. So how will I group them? I cannot group them here. See, if I say pick up the player number from the player table, there the player number is only occurring once. It will never kind of, there is no grouping that I can do. This subquery will not work. I can do a grouping here. But if I reverse it, if I say select player number from player penalties, if I reverse it, let's see if I can reverse it and do it. So I'm going to pick up the player number from penalties. Oh, but I need the name and the initials, which is coming from the first table. This won't work. I can't do any grouping here. Why? Because there is only, the player number is unique in the first table. It only occurs once. So how will I do the grouping? And I need the name and the initials that is coming from the first table. So it has to be written first and the subquery has to go inside. If I only needed the number, I could have done it. But I need their name and initials. I mean, I can make it complicated, but this will not work. I can find the numbers and then I can find the names, which is really silly, but this subquery will not give you. Think about it. Group what? There's nothing to group. The grouping is here. This can be grouped. I can do this. Instead of distinct, I can say select player number from table penalties, where this player number is in that table, and then group it. But then I can't find their, see, this I can do, but you see what will happen? I can take this select clause. I can put it here, right? And then I can say where this person is in but I can't get their names. I can't get their names. I can get their numbers, but I can't get their names. I can do this. I can tell you what they are, 6 or 27. I don't know what they are, but you can find that out. So I'm saying select player number from the table players. I can do this. Now I can do a grouping by. But notice I can't get their names is the main problem. So now you group by the table penalties player number, where table penalties player number is greater than 2. But how do they get their name? I'll have to write another I'll have to kind of encompass it in another one where now I find the name. So I'll have to put another select outside, which is like taking too much time. So do you want to see what their numbers are just to be sure that we are getting the right answer? I'm just putting the player number here, okay, to see what they are, who they are. Who are these guys that have done more than one penalties? Oops, player number, okay, PL, let's say PL. I'll remove it afterwards. I just want to see what are their numbers to show you that this is what will happen. Okay, so player numbers who have done 27 and 44. Okay, so you can get this result from here, from the subquery 27 and 44. The one that I've written, you'll get it 27 and 44. No, I have an error. Unknown columns. Oh, I forgot to put the period. Forgot to put the period. Okay. 27 and 44. See, I have the answer, but to find their names and initials, I again will have to do another select outside. Which you can, nobody stops you, but it's more work. So why would I use a subquery? So the answer is correct, but then I'll have to put another one here. Select the name and the initials from here, where the player number is in. We'll have to put one here. And we'll have to put, oh, where will the counting be now? One here. Here. So I have to put another select clause, which of course is, so the answers 27 and 44 are correct. So this, I was getting an answer. So further, what did I do? Now I again find their name and the initials from the table where it is in this 27 and 44. So I need 3 selects, not 2 selects. The subquery can be done, but it is more complicated. Definitely it is more complicated. Since name and initials are required. So you're basically working with the same table twice. The table players required twice. There is no other way. So, I mean, I've done it. So what did I do? I first found out, I don't know, syntax wise, logically it's okay, but who knows, syntax wise, it may not even work. I found out the table numbers from table players, all table numbers, but I only selected those player numbers where they were in this table. And then I grouped them and I said having count greater than 2. And this was giving me the right answer. It was giving me 27 and 44. It was working. We just saw it. And now all I've done is I've added their names and initials by again putting another one. So will it work? I'm not sure. Logically, it should. Yep. But it has become complicated. So the same table players is being used once here. It is also being used once here. So definitely it is more complicated and less efficient. The more selections you do, and less efficient. When I say less efficient, I mean from the other ones, other things, other options that I've given you. Right? So sometimes, I mean, sometimes it just takes more selects to do it. So people who are the best one, not the best one, definitely the joins are better. And of this, the outer join is the most efficient because you're saying you're here and you're not here. It is even efficient than the inner join. It is more efficient than the inner join also, because inner join also joins, it's taking a bigger table and a smaller table, and you're saying, do you have a partner? Do you have a partner? And so on. In this one, it picks up only this table and finds a partner in the other table. So it is the most efficient of all 3 solutions for this question. It's most efficient. It is efficient than the inner join, and it is also definitely efficient than the subquery, because subquery has 3 selects in it. Make sense? So again, efficiency will come with practice, and maybe a lot of practice. When you start working in the industry, maybe with time you will figure it out. Why? Because here we are not. It's not very helpful. It gives us 0 seconds. So we are making educated guesses. But when you start working in real life, you see nanoseconds also. So it tells you, oh, the query is taking this much, this query is taking this much. So you definitely know which one is more efficient. But here, from a logical point of view, from a programmer mind point of view, there are 3 selects here. Doesn't make sense. Inner join, why am I doing an inner join when not everybody has a partner. Like I only am interested in people who have a penalty. So I'll just write it like this. Now I'm not sure if right outer join is different from a left outer join in terms of efficiency. I mean, the word right or left to me doesn't make, I don't think so logically. The table that you make as your master table definitely is important. Right, so again, I've given you all three solutions, but I've mentioned that outer join is the most efficient because you're only checking the players who have made a penalty and more than two. That is a grouping, but who have made a penalty. Make sense? I know it just takes a lot of thinking, but at the end of the day, you are a programmer and you have to think. There is no way out. Okay, now it says same as question 1A, but use the exists operator. So what was question 1A? 1A was saying people who have made a penalty. Was it? That's what it was saying? Who have made a penalty. Okay, let's write it. It says people who have made a penalty. Let me know people who have made a penalty. So the best way of writing an exist, which is a correlated query, if you've forgotten from last week, is this. You write a subquery and then you change it into exist. So remember, this is a correlated subquery. We did it last week, and again, as a practice, we'll do one more. And it is in your assignment also. So how I have conquered it is I write a subquery first, and then what you do is this. In a correlated subquery, you make an inner join in the inner select. So you are saying select player number from table penalties where the table players, we'll call it P, and we'll call this one penalties, we'll call PP, where the P player number is equal to PP dot player number. And we'll write the condition first and then we'll change it. I'll repeat how you should think in your mind. So you're basically saying I'm looking for all those players such that they exist in the join of the players and the penalties table. Think about it again. I'm looking for those players who exist in the penalties table, right? That's what you want. So pick up their name and their initials such that this record exists in the join of penalties and the player table. If you kind of think of it, this inner one is a join. It's joining penalties with the player table. Look at the condition. I haven't written the word inner join, but it says where it exists in this join. You can use the player number here. You can even just say star here. It exists in this join. I mean, you can even use a star, really doesn't matter. Either will do. All it is saying is when you join the penalties and the players table, you have records. I'm only looking for those records that are in this joint table. This is a correlated subquery. So the inner where is saying the P's player number should be equal to the player number of this guy's, which is what? A join. So you're joining the players table with the penalties table on the player number. You have a join, you have many records. And from those records, you're only picking up those names and initials such that they exist in the join. Right? So when you join the penalties with the players, who will be joined? People who have penalties will be joined. Those are the only records. Now pick their names and their initials. So whenever you write an exist or a not exist, I will write a not exist for you. Now I haven't asked a 2B. I'll ask a, this is question 2A. We can make a 2B. It says same as, and we'll say same as question 1B, but use the not exist operator. I'll do it for you, right? So you are saying pick up the name of the players such that they are in this joint table. If you wanted the opposite, let's make it 2A and let's make a 2B. Let's make a 2B which says same as question 1B, was it? Let's see, was it 1B? which says people who don't have a penalty. Yep, find the name and initials who have paid no penalties. So now think about it. What are you interested in? You're interested in people who have not made a penalty. Again, I'll do the same thing. Not made a penalty. I'll kind of pick up the subquery from there. There it is. Not paid a penalty. Right? I'll come back here. This is the easiest way of doing it. Because what are you thinking? I'm interested in those players and their initials where they do not exist in the join of the table. So you join the table, the penalties table and the player, and the players table. I don't have enough space to move the mouse. Oh. Do an inner join. All this P, we called it P. And it doesn't exist here. If it doesn't exist here, they didn't make a penalty. So pick up the names and the initials of those players such that they do not exist in the join of the penalties and the player table. It's like saying it in English. Pick it up if it does not exist there. So does not exist where? It does not exist in the join. Because join is telling you, oh, they made a penalty. So if they don't exist there, they did not make a penalty. If they exist there, they made a penalty. So 2B is same as 1B, but I'm not now using not exist. So people who have not made a penalty is what should come up. So these are all people who have not made a penalty. Oh, something looks to be wrong. 1, 2. I thought Miller had made a penalty, didn't he? Give me a minute. People who have not, let's see what the answer was first. People who have not paid a penalty. Oh, I just picked up, no, I picked up the right one. People who have not made a penalty. Control C. Not Control C, sorry, run it. How many records do we have? 9 rows written. Bailey parameter PP, pillar P. Okay, so I'll kind of keep it in my head. I'm not too good at keeping it in my head, but I can remember a few things. RWS. Okay, so let's try that again. Should work. I mean, it's the same thing, just written in a different way. Instead of not in, I've said not exist, and I've given a join condition. So if you can remember it, Wise, Collins, Bishu, Brown, Hope, Miller, parameter, Bailey. Yep. It is right. So it's a way of saying you're not in that set. But instead of saying not in, I said not exists. And the set has changed. The set is now doing a join of the outer table with the inner table. Therefore, we call it a correlated subquery. Right? But we use not exists with it. That's what we do. That's what we do. So here, just so that we could revise what we had done, I just did it. Don't forget your exists and not exists. You will definitely see one question in the final exam. And the easy way of thinking is like this. That's how I do it. I'm giving you my way of thinking. It's a subquery, but it's correlated. So write the subquery first. The in one is the exists. If it is a not in, it's not exists. And the inner subquery now becomes a join of the outer table and the inner table, and just say the where condition is. So think about it. You're just saying you're here, and you're. So I'm picking up those which are in this table. Instead of using the verb in, I'm saying I'm picking up those where exists in the join of the two tables. It took a time to understand exist and not exist, but once you have your head around it, it makes sense, right? It should make sense. So yes, it is your first course. Yes, it will take a little time, but hopefully with the 50 examples I've done with you, or maybe 100 examples I've done with you, you'll be okay. Okay, let's do question number 3 now. Okay, it says, so done. We've done the exist, we've done the not exist, we've done people who have done penalties, people who have not done penalties, people who have done 2 or more penalties. Let's look at question number 3 now. It says, get the player number of the captains who have incurred at least 1 penalty. So which means, okay, they have made a penalty, good enough, but these people are captains too. And the information of the captains, if you remember, is coming from the table of teams, right? So let's look at what we have in terms of captains. So the captain is coming from the teams. So he's a player, but he's a captain. So he's a player, but he's a captain. So he's a captain from table teams, player from here, and penalty from here. 3 tables are involved. Why 3 tables are involved? Because he should also be a captain. I'm only interested if he's a captain, I want to see it. I want to see his name. So before we had 5 answers, there were 5 people who were coming as penalty payers. But are all of those captains? We don't know. I don't think so. There are less captains in there only. So we'll have to do this. So let's start. So the inner join will stay. So again, I'll just pick up 1 inner join and then we'll play with it, okay? I won't write all ways of doing it. So we'll pick up 1. We had this before. So let's first write people who have paid a penalty. There, people who have paid a penalty. But now this player must also be a captain. This player must also be a captain. So where is that captain information coming from? The 3rd table. Join it. The name of that table is table teams. And since there are 3 tables being joined, we'll have to do this player. Okay, let's go back. Think. Okay, he's a captain. He's a player. He has paid a penalty. This player has paid a penalty and is a captain. Okay, let's go back. And the captain who's coming from table teams, I'll call it TT, okay? Or just T. And the T captain, I don't have to say T, but I'm just saying it because it's kind of clear in my head that we are talking about a player number, should be equal to, you can use either P or PL, doesn't matter because they're already same, is equal to P's player number. Where? Distinct is distinct. Maybe the captain has made more than 1 penalties. I don't know. We'll see if we need distinct. It didn't say anything. It just said they are captains. So we had an answer which was, if you only run this without the second condition. Oh no, there is a 3rd join. Okay. So we had 5 people who were pairs, penalty pairs. There were 5 of them. Now we need only the captains out of them. If he or she is a captain, that's what I want. Again, I have started with an inner join. I'm sure we can do it with the inner join also, outer joins and also. But I've just started as if that's what we want. So the players, the penalties, and the teams. The players' number should be equal. The penalties should be equal. And you know, just to see if my numbers are correct. Oh, get the player numbers of the captains. We will definitely need the player numbers of the captain. Okay. So the player number of the captain is T dot captain. We don't need their names and initials actually. You'll say then don't we need the 3rd table?
We do need the third table because that table tells me, do we need the third table? Think about it. People who have paid a penalty and are captains. You know what? We don't even need the third table. I don't need their name or initials. If I needed their names or initials, then I need the third table. But if I only join my penalties with table teams, player numbers are same. And he's a captain. Yeah, I don't even need that. Because it was not asked in the question. The question just said, give me the player number of the captains who have incurred at least one. Didn't even ask for their name. If name and initials are not required, I don't need this table. I'm almost positive. Because if you look at the ERD, he is a captain and he's made a penalty. Oh, but the only problem is, but if they are related through this table, this player number here, yeah, it will work if only the number. Let's see the answer first and then removing the third table. Okay, there we are. So R. Parmenter made one penalty. He's a captain. D.D. Collins has made two penalties. He's also a captain. Double check. Are they captains? Let's double check. 6 and 27. Are they captains? Where are you captains? They're captains. 6 and 27 are captains. Now, if only player number is asked, it didn't even ask for their names, then I can remove the third table. So I'll keep this for a minute, but I'll write it again. So 6 and 27 are our answers. Their names were not asked, okay? And again, distinct if you only want to see it once. Let's do a join. Only player number was asked. This was not even asked. Remove this. Remove this table. If I don't need their names, why should I do it? There. If I get 6 and 27 still as my answer, that means I'm good. This one, if you need the name also. Right? I don't need the third table. Let's try it. 6 and 27 should be the answer. Yep, there it is. I mean, the question didn't even ask for name, but now you know that if you need it, you will have to add another table, which is okay. But the information is only coming from two tables. Who made a penalty? Are you a captain? So who made a penalty is coming from table P. And are you a captain is coming from table T. So why do I need to join the third table? I only need to join the third table if they are asking for the name and the initials, because that's coming from the third table. So don't join it. So I've said if name and initials are required, then I've kind of joined it, okay? But otherwise we don't need to. We don't need to because the question doesn't ask for it. Can you use it using an outer join? I haven't said anything. Oh, here it says if name and initials are also required. Okay, so it was there. But otherwise you don't need it. Try an outer join. Okay.
This is a small class.
Yes, it is. Your class is bigger. It's around 40ish, and this is, I think, 25 or something. Some people are missing today. 1, 2, 3, 4, 5 people are missing. That's it, right?
Oh, next week I'm coming to this class.
Now for the rest of the 2 weeks only.
Only, right?
Only. You just want to come to every class I teach. How's your back?
It still hurts, but
Did you go to the Cairo?
No, I had no time. By the time I got home last night, it was like 9.
Did you try the exercise I told
I
you?
did. It hurts, but it kind of helped.
It will help. Keep doing it.
I will.
Anywhere in the corridor also.
Thank you.
Take care. Okay, so since it is only asking for the captain number, I don't have to kind of join the third table. Okay, can you try with an outer join? How will it work with an outer join? People have paid a penalty and they are a captain. People that have paid a penalty, but they are also captains. So people who've paid a penalty is in the P table, table penalties. And they are also captain. Okay, why not? We can do it, I'm sure. Okay, let's try. Let's think which table should be, which will be more efficient. If he's a captain, then it makes sense to see if he's done a penalty. Otherwise it does, or other way around. It really depends now. Both ways we can't say anything. If he's a captain, we can check first. And did he make a penalty? Or we can say, you made a penalty, are you a captain? Now this will depend upon the size of the table. But question-wise, logic-wise, both we can't say anything. It's the same kind of question. Are you a captain? Did you make a penalty? Or the other way, you made a penalty, are you a captain? So there is no, I mean, on the look of it, we can't tell which is more efficient unless we know the sizes of the table. So I think the captain teams was smaller and the penalties was bigger, but either way, we can do both of them. We can do a left. Let's try a left first. Okay, so this is saying penalties table is going to make a left join. I think this will be a smaller table. I'm not sure. I'm not saying anything. I can't because we don't know the size of the table. Let's try to do what does this do. Okay, so the penalties table is trying to find a partner, but that partner should be a captain. So if the captain is null, that means he's not a captain. Okay, so join the condition. So this looks as how much? 1, 2, 3, 4, 5, 6, 7, 8 records came up. Okay, but we have to remove, we have to filter it. Where captain is null. Notice how the captain, which is or team number is null. Team number is your primary key. You can say where team number is null, or you can say where captain is null. Both will work. Actually, all three fields work. We always try to go with the primary key. We kind of try to go with the primary key. If the team does not exist, the captain does not exist. So I'll go with team number. Okay. Just because these are people who have the numbers of people who have made and are captain is not null. I want the is not null. 6 and 27 is what I want. So this will work now. So not null will give you 6, 27, 27. Yep. And then distinct will give you. So there were 8 records. I'm going to do the same thing now. Just I'm going to reverse the join and see how many records do I have. That's the only way here I can tell you which one is more efficient by the size of the table. So we will run it till here again and see how many records do we have. Because logic wise, it's the same question being asked. Okay, let's see. This table this is just smaller by virtue of the table being smaller. There are only 3 teams. Therefore, the teams table is smaller. So in our case, this is more efficient just because our team table is smaller. But otherwise, question-wise, logic-wise, I couldn't answer it without looking at the result. So this table is smaller, the table teams is smaller, and therefore we have less result. And what should we keep? Where player number is not equal to null or payment number is not equal to null. So we'll have to change it, where payment number is not equal to null. So be careful what you have to keep. You have to keep these where payment number is not null. Whose payment numbers? Penalties payment numbers. And again, payment number is the
key field. So payment number is not null, keep it. Put distinct there. And I'll say is more efficient just because the teams table is smaller in size. Teams table has less records. That's the only virtue of being more efficient. As I said, on the look of it, we couldn't have answered it. Because we don't know. There could be more teams, there could be more penalties, who knows? So who knows? We can always do a count. We can know the size of our table and then we can use the required. So more efficient just because the teams table has less records. And which ones do you want to keep? Where the payment number is not null. Be careful where the payment number is not null. So, and now we only want to see it once. Oops, now we only want to see it once. And it should work. There it is, 6 and 27. Okay, so since only payment number, since only the captain number was required, we are okay with two tables. As soon as name and initials are required, it will get complicated. Okay, now can we do it with a subquery? Oh, subquery is also written. And name and initials are also required is written. Everything is written. I just haven't done it. Okay, the name and initials we'll do next time just because it's more time. But the subquery we can do in 4 minutes. So people who are captains and have made a penalty. Okay, find out people who are captains. Select captain from table teams. Okay, so these are captains. Now select those player numbers and distinct. Those player numbers from the penalties table where the player number is in this set. And we don't have to do a distinct in captain. There is only one captain per team. This should also give you 6 and 27. There it is. Right, so he is a captain. Did he do a penalty? Now, just because I said, and if you can make your thinking with the exists, do this. So select those player numbers from the penalties where exists. It's still a subquery. Select captain from table teams where this captain is equal to the player number. See, if you know how to write this subquery, the correlated subquery becomes easy. All I did was with the query, with the subquery, instead of in, I changed it to where exists, and I put a joining condition inside. Because you're saying that this player number is in this captain. You know what I'm saying? Like this player is in this captain. And it should give you 6 and 27 again. There it is. So going from a subquery to a correlated subquery is easy. It's the same kind of concept. You are here and here. You're in here. So you're basically saying where it exists in the join. So definitely the correlated subquery is more complex and less efficient because it's doing a join and then doing a select. Whereas this is doing a select and a select, but join is definitely more, takes more time than a select. So the one which says you want, names and initials, will come back to it afterwards. Where names and initials are required, we'll come back to it next week. Right? I've only answered the captains for now. And captain numbers. And I've done one of them with with the name also. I've used an inner join, but not with the outer join, not with the subquery. I've not done it with anything else. I've only done it with inner join. So we'll come back to that. That thing and the question number 4 we'll complete next week. And then anything that is left, I'll complete next week because that's my last week that I see you. Okay. Okay, so I'll put this on Blackboard for you just in case you're interested. Okay.